So hello everyone, and welcome to this event. We are going to be starting in a few seconds. I can see just people just joining to the Zoom conference. I will wait a few seconds and then we start. So yeah, I can see still people are joining. Okay, so hello everyone and welcome to this event brought to you by Mercy and Western Cheshire Local Network. This event is organized by Biomedical Engineering Group and is hosted by myself, Ashkan Eliasi, and my colleague, Dr. Andrew Caldos. So I will provide an introduction before handing this to our speaker. So the aim of the Biomedical Engineering Group is to raise awareness and further knowledge in this multidisciplinary field, support the industry to advance through networking opportunities, and connect and give voice to active individuals and share knowledge. So the group was recently established and we are looking for volunteers to join us in the steering committee. And if you are interested and worried about the time, so I just want to say that we are not going to ask for more than 5 hours of your time per month. And the benefits include influence in the direction and activities of our group, extensive networking opportunities, support for CNG registration, and it will be a valuable addition to your CV. So if you would like to learn more about this, please drop me an email and I will provide more information. So today's event is using the Internet of Things for healthcare to help with the tracking of medical devices. And our speaker is Mr. Mckean. So Mike has an electronic and communication background, which began as a technician in the Royal Corps of Signals in the 70s and 80s. Even in those days, well before the internet, he was involved in the network systems. In his last few years in the military, he was assigned to design and build non-standard communication systems. In days that involved TTL and CMOS ICs and CPUs running at 800 kilohertz. CPUs now run well over 5,000 times faster. Mike stays up to date with the technology. To do that, he organizes 2 technology meetup groups. One has a focus on Node-RED, a simple flow programming model, and the other one, AWS, Amazon's cloud service. Separate from those groups, Mike is also working with NVIDIA Jetson 2 GB dev kit, GPU and CPU to gain an up-to-date understanding of Docker technology and machine learning. He is also the chairperson of the IoT committee at the Institution of Engineering and Technology. That committee has a global responsibility across all 168,000 members of the IoT. Mike is supported by 9 members who hold PhDs and advanced degrees and are mostly involved in academia and research. Mike is an advisor to the UK MOD SAPIEN panel, which is managed by the Defence Science and Technology Laboratory, which is an agency of the UK Ministry of Defence. SAPIEN is a middleware used to exchange data between autonomous sensors and battlefield command and control systems. Mike has an HNC and a BSc in technology-related subjects. So just some housekeeping before we start. The presentation will take 30 to 45 minutes, and then it will be followed by the Q&A session. Please use the question box to post your questions as we progress through the presentation. The session is recorded and it will become available within a few days on the IIT website and our YouTube channel. CPT certificate will be provided on request. So if you need a certificate, please drop myself or Andy an email and we will provide you with the certificate. And lastly, on behalf of Mercy and Western Cheshire Local Network, I would like to encourage you to come to events, involve your company, and join a group. If you would like to inquire more about our activities or get in touch, there are a number of people you could contact. So myself, as the chair of Biomed Group, Andrew Caldos, who is the chair of the Management and Manufacturing Group, Rob McDonald, who is the chair of the Local Network Group, and Godfrey Evans, who is the deputy chair of the Local Network. So without further ado, I would like to invite Mike to share his screen and start his presentation. So Mike.
Okay.
Excellent. Yes, we can see your presentation.
Okay. Right. So what I'm not going to read out all the words. I use PowerPoints as a guide to what I'm going to discuss. Now this is live. I'd love to take your questions real time, but the process is you send the questions in and they go to Ashkan and Andrew, and then they will then combine them at the end of this presentation and ask me the questions in real time. As we go through this, if you think of things you want to ask, and you either don't want to make them too public, then please email me. My email is at the bottom of every slide. The way this works is that I give the presentation, and normally your questions go to Ashkan and Andrew, and they, if we have time to answer them now, we do. If not, they send me a spreadsheet later on. I don't have your email addresses, so I just send the answers back and they distribute the answers to you. But please feel free to email me. I'll be really, really pleased to help you. The more questions you give me, the more I learn. Right, so let's start. This is the agenda, and I'm going to give, this is, we agreed this would not be too technical, but I need to give you some briefing on the technology. The important part here is in these two lines here, non-intrusive tracking of medical devices and integrating. And I'm going to touch on things like HL7 and other technologies, just a high level, and then risks and problems. Obviously, in any environment, changing technology is a risk, but in the healthcare medical arena, it's even more so. And at the end, there's a Q&A. Now, as Ashkan quite rightly said, we've done a couple of practices, and this presentation typically took about 35 minutes, but it's live. So it depends how it goes. It could take 30 or it could take 40, let's see. I've got a couple of slides from PricewaterhouseCoopers. So PwC is a very, very large consultancy, and it helps a lot of industries, including healthcare. And by the way, it's hard to read this text. So if you want copies of these slides, please email Ashkan or Andrew, and they will send you copies of the slides. The important part here is it sets the scene. And obviously on the right here is talking about aging population, problems with ambulances. And I see this, by the way, I have done several medical projects, and I'll touch on one later on. I'm under very, very strict non-disclosure agreements, but I can talk about the project in general or projects in general. So this slide sets the scene, i.e. technology can be used to help improve healthcare, etc. The next slide is actually a bit better. It gives some facts and figures. So on this one, this is also from PwC, and I positioned this presentation about tracking assets and managing assets, i.e. facilities management in terms of assets using the IoT. And it's down here, it's towards the bottom at 33% for companies who have already deployed this technology. But if you read the text, it's actually all about tracking the devices, knowing where the assets are. Okay, so although I'll explain later on how I've found that IoT helps improve the efficiency of doctors, of medical staff, but it also improves the confidence that patients have with how they're being cared for. And it can also offer your procurement staff very substantial bargaining power with the medical machine manufacturers. So a lot of detail here. The rest of my slides don't tend to have that much detail. I'm very much a hands-on sort of person, but contact Ashcan for copies of the slides. Okay, here's the technical part. Right. The Internet of Things arguably started in 1969 in America with two universities connecting two computers where they had files on one computer and a leased line between them both, and they shared files between computers, and that was arguably networked computers. And how has it changed? Well, that leased line has changed, and there's a network of computers in a cloud, and they called it the internet. And then you connect, both computers connect to the internet. So that's the very brief introduction. What they did on the left was, rather than having a computer, that thing might be a gauge or something else, or a meter of some description. And they had even smaller things, smaller computers. So the thing on the left became a very small computer that might cost maybe 40 or 50 pounds. Those that don't know or know, there's something called a Raspberry Pi. Those are schools and lots of technical people use them for projects and get a really small, inexpensive computer at the end. Again, meters and things, thermometers, temperature gauges in machines and hospitals, wherever you want them. And this is an intriguing one. So what they also did was, if you have, if I go back one to this device here, you can get some really inexpensive devices that might measure temperature or strain or something. And then to report back the data through the internet to the backend databases and computers, it quite often, they don't want to connect to the local area network, to the hospital network. They connect using a mobile cell phone type card, a SIM card. And let's imagine you've got 1,000 of these sort of devices in your hospital environment, and you're reporting back every 10 seconds. That's thousands and thousands of calls being made back to the center just to say the temperature is normal, there's nothing happening. So what they do, what happens in a lot of internet environments is you'll put something called, it's called either a gateway device or a concentrator, and that will connect back to the internet. But importantly, it'll also connect to maybe 100 of those other type devices. And if the data coming from those other 100 devices is just everything is normal, there's nothing to report, then it either won't send anything back or send a shortened message saying everything is within limits, or of the 100 things I'm looking at, 2 have an issue. But this is about medical devices, and I'm talking about tracking them. How do you do that? So this is being blown up. It's 90 millimeters. So in old money, that's a little under 4 inches. And how is it deployed? So it's very small, and it's connected to a medical device. And typically it's either screwed on, or it's glued on, or it's affixed in some way you want. And that device sends messages and data to some sort of concentrated type box. It's about, this one happens to be about 10 inches by 7 inches approximately. And this might be in a ceiling void, or in a hallway somewhere, away from people, that people can't touch it. And as these devices are moved around the hospital, they send a signal to this device saying, this is where I am. And that connects back to a database. I've got another slide with slightly more detail on this, but it says, it tells you what it is. It's a ventilator, ultra scan machine or something, and where it is, and it might give you a serial number or something. And that data is then sent to the medical practitioner or the practice manager, giving him or her details about where all the machines are. Now, I'm showing it connected to that machine, but obviously it can connect it. It's still here. It doesn't show up very well if I move over there. It's still here. It connects to that medical machine. However, it doesn't have to be medical machines. This happens to be a high value floor cleaner. What the point is, These devices can be used to track anything, and as you probably know, you can apply. There's several types of these emitters. Let's call them emitters. Some are Bluetooth, some are something called RFID, and some are Wi-Fi, and some are those have batteries in. Some are actually those are called active devices, i.e. they emit a radio signal. Other are what's called passive, and what happens is the device, if it's passive, it's like when you go into the shops and buy your steak or whatever that costs £3.50, or you go to a shop and you walk out the shop and they've left a tag on your clothing, and you walk through the scanners, the alarms go off. Those tend to be what's called passive. The range is only maybe 1 or 2 meters, and they're very cost efficient, very low cost. The point is, you can start tracking things like gallon containers of floor cleaning fluid, or obviously you can track higher value medical, clinical devices, etc. The point is, you can track anything with this sort of technology. You can track people with ID cards, etc. Let's look at this a little bit more. And remember, I said non-intrusive tracking. So let me go back one. This has a small battery in it, and it typically lasts 4 years, secure to the asset, however you want to secure it. And that's the same concentrator box, range 100 meters. Is that a good thing? No, it's not. Let me explain that comment. If you've got an ultrascan machine and it's within 100 meters of this device, that's not very good, because that 100 meters could be upstairs, downstairs, in any one of 2 or 3 wards. So what you do is you put different types of machines. Something called Bluetooth has got something called beacons, and they can be anything from like 2 or 3 meters to 100 meters, depends. This happens to be like an RFID one, but you have a mix of emitters in your hospital. And this box is a small computer, and it can work out, I'm getting signals from the following emitters. That machine is almost certainly in Ward 2 on the 2nd floor, for instance. And then this concentrator device typically will have what's called a local area network, or a LAN type connection, and or possibly a Wi-Fi connection. So it might connect to the hospital network directly via cable or Wi-Fi, or it might go to the internet or a cloud. And again, it's just sending that data back to the database, which goes to the medical practitioner. Now, this is really important, and I'm probably going to talk about this a little bit more detail. And I said integrating asset registers, integrating your systems. Those of you who are technical will know that integrating anything causes trouble. And there's 3 things I'm going to touch on. The first one is HL7, which is a method of sharing data and information specific to I'm going to call it the health industry, into the health sector. And that's used to transmit data about patients and other things between hospital applications. And that's the first thing we have to look at. The second one is different data protocols. Now, I don't mention my employer in these videos, but what I will tell you is that I work with many different manufacturers of equipment. And in the medical world, what happens is risk is so important. If you're a clinician and you're with and trained on ultrascan machine made by machine manufacturer A for Alpha, and you're comfortable with that, and the hospital starts buying lots of that machine type, it's relatively high risk to start changing that machine. So what you sometimes find, not always, what you sometimes find is that hospitals might standardize on certain machines wherever possible. And the reason is it's lower risk. It means that doctors don't need to, it means that clinicians don't need to be retrained. And what that means, what those medical machine manufacturers do on the data protocol side is they like to keep that proprietary. And what that means is it's not a standard, easily understood data protocol. And it means that once the hospital buys 2 or 3 of those units and the doctors, clinicians become comfortable with them, it's hard and high risk, to be blunt with you, to ask the clinician to move and try something that's better, cheaper, faster. I'll explain that more in a minute. And the last one is databases. Again, those of you that are technical will know that database technologies are, I've done a lot of work with big banks, and say is, data is critical. Think of your bank account. You don't want to go online and find your money's gone. So it's the managing databases and is crucial in any sector, but more so, as much as it is in banks, even more so in the medical healthcare environment. So let's touch on HL7 first. Do you know what? I'm doing this live. I wish I could see you. I wish I could take questions real time, but let's keep going. HL7, I was going to say there's two versions. There's not really, there's far more than that. HL7 version 2 is a series of versions, as it were, and I don't know if it's 8 or 10 of them, there's lots of them, and that's been around for a long time. And HL7 version 3 has come out recently, the last couple of years, and XML is the preferred data markup language. What that means is how you're going to format the data. And that's quite good because XML is well understood by technical people in a standard format. So if you're in the healthcare world, you've certainly got HL7 version 2, and you've very likely got a version 3 as well. But how do you integrate them both? You need some sort of converter to convert between HL7 version 2 and HL7 version 3 stroke XML, and I'll come on to that now. So, this is the organization, HL7 UK organization, and at the bottom right here, they're confirming that XML is a preferred implementation technology. So the point is you need to convert to integrate HL7 version 2, you need to convert from one to the other. Here's a slide I was going to talk about. The IET, of which I'm the chair of the IoT technical network globally, we are not allowed, I'm not even allowed to discuss my employer because it's a charity. We're not here to promote companies. So when you look here, I've deleted the companies, but your technical people will be able to do this. So if you need to integrate one with the other, I did a search on converting it and I limited the responses to 2020 and 2021. And despite that, I got 1,700 results. The point is, there's lots and lots of resources. And if I was your technical people, I'd suggest look at open source and build a small proof of concept offline and do your testing. If you need to do that, then do it. It's a great way of converting one to the other. The next one is different data protocols, and this is where the medical machine manufacturers are not as helpful as you might like them to be, because as I said, once you start buying their equipment and your clinicians become comfortable with the look and feel, it's high risk to move. So let me go back one. And in my role in the military, I'm civilian, but I'm ex-military, and I have a role with the military where there's about 50 companies, all the big defense companies are involved, and it's to do with autonomous sensors. And this is where you're using robots and drones going out into battlefield environments and communicating back. And the vendors were trying to lock the military into XML. So I've just said XML is great for HL7. Yes, it is. But I wasn't comfortable about them locking the military into XML. And in my role, I am responsible for steering the technology from what they call a generic system instantiation, which means it's like a trial, to a specific system instantiation, which means it's production, it's for real. So what this is, I'll explain what this is. This is a recording I'll play in a minute. And although we're talking about the military, this is the same for medical, the same sort of technology. So those of you that are technical at all will know JSON. JSON's very popular with younger developers. It's very prolific in the IoT, in e-commerce. It's very, very popular. XML is well known, a little bit older. Protobuf is less well known. It came from Google, and I'll actually start this in a minute, but I want to show you what it is. So imagine, rather than sensor ID being engine upper floor 10, imagine it's ultra scan upper floor 10 or something. You see it says sensor ID engine upper floor 10 there. It says the exact same thing here, engine upper floor 10 here. Engine temp 153, engine temp 153. The point is, behind this, and I'm going to play the recording in a minute, is a converter that I made, which converts XML to JSON to protobuf. You can't see protobuf because it's in a different type of format, And for the military, this was earth-shattering. What it meant was that the devices they have, the drones and robots they've got in production and in trial that are based on XML can now be integrated with newer machines using other technology. The technical people will recognize this. XML uses 269 bytes, JSON about half as much, and protobuf about a quarter of that. And protobuf is very popular in the military in real time. You want real-time communications. So I'll now play this very briefly, and you'll see these changing, and they all change in sync. This is about every 1.5 seconds. And the point is that if people, you will find this, I promise you, you will find this. Medical, and I've worked on big projects in Europe. Medical device managers will say, you can't do it. It's not possible. You can't convert one to the other. You can. And by the way, this is where you're, what we can also do is, the problem with converting the protocol is only part of the battle. If you've got an ultra-scan machine that your staff are comfortable and familiar with the look and feel, and you're viewing that remotely via a laptop or a phone of some description, what we can also do is change the look and feel. So if you're comfortable with ultra-scan model B, but the machine you're viewing is actually ultra-scan model A, you can see it in whatever format you want. There's a limitation to that. If the machine, sorry, I'm getting a bit complicated here, but you can only view what the machine produces, i.e. if the machine is not producing something that another machine produces, you can't see it no matter what we do. But that's where your procurement people come in. That's where you say, we want to look at buying new medical machines. What can you offer? And you say, you must be willing to share the protocol with your technical people. And by the way, you can reverse engineer this. That is not a good idea, because all that happens is that the medical machine manufacturer, they might do a firmware update 2 or 3 months later, and it no longer works. So again, your procurement people come in and you say, in future, when we buy ultrascan machines, please will you be willing to share the data protocol you're using? And it's nothing special. It's Modbus or it's Profibus. They're all standard things. They just change a couple formats. That's all. It's nothing clever. Nothing clever at all. Let's move on to the benefit. By the way, is that the benefit. Let me move back to that. Stopped it. The benefit is that the doctors or the clinicians can see the data coming from that machine in their preferred format, so the clinicians don't need any retraining. The benefits to the procurement people is that they can go out there with your engineers, with your technical people, and say, what's the very best machines on the market, which have the best functionality, and what's the best price. You're no longer locked in to those legacy machines. That's why I've labored on this. I apologize, but it's been a big problem I've seen in the past. Right. Different database technologies, and this is important because, you know, when you say to people, how long do you want to store your data for? They say forever. And it's true, you need to store it for a long time, and it needs to be, the data integrity needs to be accurate, it needs to be correct. And there's different database technologies. So here's a fairly simple one. And what we've got here on the left is an older database. All it's got is 3 columns, and you want to move it to a new type of database. It's going to have 4 columns. And I know I'm being very simplistic, but that's it. You make a design for your new database. You speak to your technical people and tell them what you want. Hold on, what's next? Here's what's next. You still need to look at. So I'm just moving something. You still need to do some sort of database migration. Now, I left this pretty open, and I got 415 million results. Now, if you look at my LinkedIn, I also I run a technology meetup group for something called Amazon Web Services, or AWS, and I give presentations on that. And people go, "Oh, you're locking me into AWS." Yes, but you can get out again. So in the IoT world, I'll be very, I've got some slides at the end, but I'll be very brief. The main parts in there are the broker and the database. And what I do is the AWS database is something called DynamoDB, which is a NoSQL database. And I use something called MongoDB. That's specific to AWS, it's proprietary. I use something called MongoDB, it's very similar. and I can show people in real time how I can move them in and out of Amazon. It's really easy. Amazon is great and I love it. I'm just saying, don't anyone tell you database migration is difficult. It just needs planning, that's all. So if you're going to integrate your assets in real time, just to summarize, you need to think about what versions of HL7 you've got, 2 and 3, the data protocols. Your medical machine manufacturers will not be as helpful as you might like. Get your procurement people to encourage them by saying, if they want to be considered for the next procurement round, then they need to share data. And by the way, they don't have to change their data. Nothing touches their system. The technology I'm talking about, IoT, are outside of their box. And then the last bit, the different database technologies, there's lots of solutions to that, and your IT people will know how to solve those problems. There's lots of resources. Again, a lot of them are open source. I'm going to talk about an example of I've got NDAs signed with the medical services company, the national. This is not Europe. It's not UK. It's one of the biggest countries in Europe. It started pre-COVID, believe it or not, and it's for ventilators. Pre-COVID for ventilators. What a stroke of luck! Sorry, it's a long thing to say. What it was a project that was launched that benefited that country. So anyway, and I'm under NDAs with the machine manufacturers because they went through the same thing of not being as helpful as we would have liked. And it was ventilators, several thousand, in hospitals and at homes, different manufacturers. And what they wanted was what I've described, which is they want the clinicians want data from several different, and I've got a slide on this in a minute, which will show it better than my explanation. They want to see this, the data from the monitors, they want to see data from the ventilators, and when you infuse gas chemicals into the patient, they want it all in sync to the subset. I was surprised that they wanted to see the data synchronized. That's quite a challenge actually from different devices. They want to see the data synchronized so that when someone breathes in some sort of chemical or gas or whatever treatment they have, they want to see the output in the monitor in real time. They want to see it all in synchronized. They want to see the screen with the ventilator at the top, the monitor below it, etc. And they want to see it in the clinician's own point of view, or whatever they're most comfortable with. That means that you don't need to retrain the clinicians. And it means there's no changes to the medical device manufacturers either. And it also means from procurement, by the way, my company doesn't sell these boxes, but it means for procurement can go out now and say, right, I can go and talk to my engineers, see what the best systems are, and look at buying the lowest cost devices, because using IoT, you make box A, device A look like device B, etc. The patient, what about the poor patient? The patient's at home or in a ward at the other end of the hospital, and they're connected real time to their doctor or any doctor on call. And that doctor can receive alarms, alerts, sub-second, whether they're at home or ward 10 on the 10th floor, it doesn't matter. And this is specific, the main focus here was ventilators. And unfortunately in this role, a lot of the people were terminally ill. And by the way, in this example, no identifiable data about the patient is transmitted from device to the back end. Let me explain that. How does it work then? What happens is the IoT gateway has let's call it a reference number. So you don't, for those that are technical, you don't use a MAC ID, you don't use the IP address. There's no patient identifiable name or anything at all. What happens is that the ventilators, monitors, and other equipment connect to the medical, to the gateway and send their data. And that data is tagged with that IoT gateway identifier. That message is then sent to the back-end medical database, which is HIPAA or GDPR compliant. So back in the healthcare environment, what happens is that IT gateway identifier is then linked up with, this is Mike Mckean, this is his address, this is his background. So the point is that although the data is encrypted to military standard from end to end, there's still no patient identifying data sent over from machine through the internet. Sorry to labor that, but it was really important. And this is a huge project that's bringing significant benefits to everyone. So I'm going to go through that example now. So remember one of my first slides about the internet with the computer on the left? Just watch what happens here. So on the left, I've colored them red, blue, and green for a good reason. They're different. I'm not going to mention ventilator manufacturers' names. I would get fired. They're different ventilators with different buttons, different displays, and each patient, there's a little gateway connected here and here, wherever it is, and here, sending the data, as I've just described, back to the internet. At the other end, and this clinician down here in blue, he particularly prefers to use a laptop. Another clinician uses a mobile phone or an Apple, whatever, and a desktop. And either of them can see the data from different machines, but in the format they prefer. So if they want to see oxygen levels in green, sorry, in blue and purple or whatever, that's what they see. But this clinician wants to see them in yellow and green or whatever, they see it. So they see the exact same data comes, but they see it and they prefer, and once they log in, they see the data in the format that they prefer. So this now means that you don't have to swap out devices at this end. You don't have to retrain any staff. The patients are immediately supported by the clinicians. And for this poor patient at home, they've got immediate attention. It's a lot of reassurance for these patients now. They know they've got instant service. It's absolutely fantastic. That was one of the major benefits, is it confidence for patients. And these clinicians now, they don't have to run around doing things. They've got them, they're very busy people. They can access things on their mobile, laptop, etc. And importantly, they don't need to have retraining. Whatever they like to see, the format they like to see data in is the format they see the data in. So risks and problems. I know I've labored on this, but vendors want to lock you in. So reminder, get your procurement people involved, explain to them that you want them to share the format of their data. They don't make networking equipment. They just take networking equipment and it's made by a small number of companies. It's just chips. No, the very worst they'll do is change a bit sequence or something. It's not hard to, you can reverse engineer it. It's not worth it. Get their buy-in. And the way to do that is ask your procurement people. You just need one manufacturer to break ranks and say they'll cooperate. And if not, find another one that's willing to do it. And once you get one, they'll all come on board. I promise you, it happens all the time. The next thing is, I do a lot of work in different environments, but yours really is life and death. So you start with what's called a proof of concept. And this is how we always do it, especially in health. You get a ventilator, a monitor, and some other equipment, and you put it in, you get a room allocated, and you put it in there. It takes a couple of weeks to get the technology working. It then takes a month or so to get the medical staff to agree with what they want. And I'm saying that because people have different preferences. It's subjective, you know. So plan for a 2 or 3 month, I'm going to call it a proof of concept. Several different technologies. There are things like, remember there's the HL7. There's then the data markup protocol, which is from the medical device through to the gateway. And then at the back end, there's a database. There's more to it than that, but that's a summary. Then whose budget? Is it IT? Is it medical? You need to work out whose budget is. Generally, you will save money because you can now buy systems from anyone and there's no retraining. So you will save money. The biggest problem is the last one. I know healthcare people are so busy. I mean, you're awfully busy. This can be seen as a nice to have, but if you want to be more efficient, then try and find some time to do this. I apologize. I know you're also very busy. Questions. So on the questions, my email's at the bottom of the slides. So if you ask me questions now, I will try and answer them. What happens with the presenters is that Ashkan and Andrew, when you send questions in, I don't see the questions. When you send them in, they'll get a list of questions. Those that don't get answered, they send to me in a spreadsheet. I don't have your email. All I do is get a spreadsheet of questions. I then return the questions to them with my answers. It takes about a week or 10 days for that turnaround. If you got complicated questions, please send them to me. If you look me up on LinkedIn, I actually enjoy this sort of thing. I do lots of different webinars. It helps me learn. So please don't be shy. If you've got questions, email me. Okay, let's move on to the real live part where I get some questions. I'm going to stop sharing.
So thank you very much, Mike. It was excellent presentations. I really enjoyed it. So I see the questions are coming. I would like to just invite Andy to join us and help us with the questions, please.
By all means, it's my pleasure to join you in asking the questions. Thanks, Mike. That was really excellent presentation, and it's really
almost on time.
Very informative. Very informative. Okay. You are on time. It's all right. It's okay. Oh, the questions are pouring in. The first one is from Bog. How does a mobile device know its location? Presumably, devices can be in a health center or off-site.
Yeah. Okay. So there's a couple of things here. We'll talk about the medical device. So we're talking about the medical device which has got some sort of emitter on it. The emitter does not know its location. So what happens is the emitter just sends out a signal saying, the emitter has like a reference number, a reference code, a designator saying, I am emitter number 145721 alpha beta, whatever it is. And it's moving around. It doesn't know its location. Remember that white box in the middle that was about 10 inches by 7 inches? So that's a fixed item. And what that does is when something comes close to it and says, hi, I'm emitter 147524, that little white box is actually a small computer, and it says, so you know where that white box is. That white box is in ward number 3. Mm-hmm. And as that device, as that emitter goes past it or comes close to it, that little white box says, emitter 13457 has just come close to me, and that sends the data back to the database, which publishes it saying that ultrascan device is now in ward 3. I hope that helps. If not, email me, but I hope that answered the question. And there's lots, there's things like there's beacons and that I'll talk about if I get on. I'll try and keep my answers short, but if I don't answer properly, please email me, or if your question's not answered, please email me afterwards. Next one, please.
Thank you ever so much, Mike. The next one is from Ed. How do you deal with change data definitions, e.g. Brand 1 calls a mode pressure control and Brand 2 calls it BIP, whatever it means?
Say that again, Andrew.
How do you deal with change data definitions, e.g. Brand 1 calls a mode pressure control and Brand 2 calls it BIP?
Yeah, good, exactly. So let's assume that they're both, thank you very much, great question. So let's assume you've got a medical device that's going to send 10 different metrics, okay? And you've got another medical machine that coincidentally also sends, let's keep it simple to begin with. So device 1 sends 10 data metrics numbered 1 to 10, and device 2 sends 10 data metrics, and they're not numbered 1 to 10, they're A, B, C, D, E, F, G, H, I, J, whatever the 10th letter is, okay? If the metrics are all exactly the same, then in IoT, in the display, you just change the display to say the metric coming on labeled as number 3 is actually the same as that coming from another machine, which is letter C for Charlie. Mm-hmm. That's a simple version, but what you sometimes have is that medical device A for alpha might give 12 metrics. It might provide 12 things, and the lower cost machine or the other machine only provides 10 things. Mm-hmm. And that's when your engineers have to work out, are we going to buy the machine with only 10 metrics, yes or no? And then what you're saying is those machines with 12 metrics, then you publish their data, but if the doctor's view is that it only accepts 10 metrics, then he or she can only see those 10 metrics. So I hope that makes sense. So basically, whatever the metric is, it'll have some sort of what's called a markup tag, a markup language, and it'll say this is blood pressure, and this is what the value is, or it'll give the blood pressure a different way, and this is what the value is. So as long as it emits what's called a tag or a label, mm-hmm. then we can receive that and display it. And it doesn't matter if it's in a different tag, as long as it's blood pressure, we can receive that and display it in whatever format someone wants, even language, etc. I'm not sure if that answered your question or not. If it didn't, please email me.
Thank you very much, Mike. Excellent. Next one is from Colin. It's a very short one. It's a good one. What is the preferred data transfer mode? Is it JSON?
Okay, so it's none of it's a great question. Okay, so JSON's really popular with people in modern. I don't know if you can see my face or not. I don't know if you can, but I'm a bit old. If you look at my, I'm a little bit older than most. So JSON's quite a modern technology, and it's very, very popular. So I would say that if you went to, one of the things is in the IT, you don't always choose the best technology, because you need to choose a technology for which you've got developers or staff who understand it. And XML and JSON are technologies that I'd say you're certain 100% to have staff who understand them. So, and JSON is something you can get lots of developers who understand JSON. So JSON, I would say, is very, very good. I'm not going to say it's the best. I don't think you can see my face. I'm not saying it's the best. They're all very effective. You choose, personally, I go for the technologies that the established customer is most comfortable with. You know, they understand JSON, for instance, and you might look at another one for legacy reasons, and you discuss with them, and maybe another one for special case, you know, for some special case. Yeah. But JSON's a safe bet, Colin. You're absolutely, if it's Colin, you're absolutely right.
Yes, yeah.
JSON's so, really good.
That was Colin's a sort of choice, perhaps. Yeah.
Yeah.
Okay, thank you, Mike. From Don, I assume the data passed doesn't have any control function on the equipment. Can you confirm that? The data passed doesn't have any control function on the equipment.
Right. So you're correct. So the way this, and it's a really, the data can go two ways. So let's keep it simple to begin with. So the data tends to come out of the serial port. So for those that are technical, usually it comes out a serial port, RS-232 or RS-485, or an Ethernet port, usually. And it's comes out of the Ethernet port from that port from the medical device into the gateway, and it's then sent without any modification at all in real time to the hospital at the back end. The important thing here is to meet medical requirements. The gateway device, so I mentioned gateway device, it must not make any medical decisions about what it transmits. So in the industrial world, so let's park healthcare for a minute. In the industrial world, if you're reading data from a machine and the temperature and operating parameters metrics are within limits, why send that data back? There's no point. That's not the case in the medical world. In the medical world, you send the medical gate, the IoT gateway must send everything back, because the IoT gateway is not a clinician. The IoT gateway is not a medical application. So just to labor that point, the gateway sends 100% of everything it receives from the medical device back to the back-end application, to the medical practitioner, and he or she then makes a decision on what they do. The controls you're talking about, you might have been talking about, I'm not sure. These gateways can send data two ways. So they can send control functions to the medical device. They can also receive data such as the medical device itself is getting poorly, it's getting hot, or you might want to do an upgrade to it. So those things are done what's called out of band, or a device management mode. So medical information goes one way, but the gateway can always, if set up and allowed, can take action on the medical device if allowed. Sorry if that's a long answer, Don.
Well, it was a quite comprehensive answer. Thank you very much, Mike. Well, Colin has come up with another good question. What happens when systems go down and your real-time feed stops? Yeah. What level of resilience is baked into these system, these mission-critical systems?
Okay, so it's not. Okay, so if these systems go down, so what you've got is a medical ultrasound device that's working. It's working. Hold on, you don't stop that medical device working. So that medical device is connected up to me. It's an ultrascan, whatever, or a monitor, a ventilator. It's connected to me. It's working, and it's keeping me alive, or it's monitoring my condition. It keeps, even if the IoT gateway breaks, that doesn't stop the treatment to the patient. The treatment will still go on to the patient. So there's a number of ways that IoT gateway can break. Let's look at them in order from what's called the northbound side. The northbound side is what they call towards the cloud. So if the link to the cloud goes, whether it's let's look at being like a cellular connection, that's quite often done, then most gateways will have what's called two SIM cards, and it might try the one or the other. It's got what's called a watchdog timer, and it'll say, I can't see the cellular signal, I'm going to reboot it. Then things like the field side or the southbound side to the device might stop working. And again, there'll be watchdog timers to say something's happened, I'm not receiving data. Or the device itself could break, or the power to the device could break, and they could be battery backed. So if the device, and also there's devices, the gateways tend to have they all have a micro SD card with enough storage to handle data locally. So if the WAN link goes down to the back end, then it can store data typically for a month or two. So if the gateway fails, the patient is not harmed in any way. The treatment keeps going. The central site has a heartbeat, maybe it's the wrong thing to use, but has a pulse that goes to the gateway and says, oh, I've not heard from the gateway for 10 seconds, it's a problem. So if that's at someone's house, they'll say, oops, the gateway stopped working at that person's house. Let's give them a phone call or send someone down there to fix it. So the gateway is an add-on complementary thing that helps. You could have two gateways, but then you have two mobile lines, two landlines, it says. So the gateways there is an added value to the patient. And by the way, these gateways don't have an on-off switch on them. So we've had them running for 17 years, 17 years. They typically run, these are industrial gateways that tend to run in dark places in cupboards, with no moving parts, no fans, nothing. And they're very reliable.
It's very impressive, Mike,
Right.
really. Thank you. Well, Colin
Thanks,
has
Colin.
raised another one. Do you bake in any messaging broker like ActiveMQ or RabbitMQ queuing?
I like Colleen. Colleen's
So do I.
Is it Colleen or Colin?
Colin.
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 Right. So great question. So there's two common methods of connecting internet or IoT to clouds. So the major clouds, Azure, AWS, Google, etc. They typically accept two types of protocol. One's called MQTT, another one's MQTTS, another one's called HTTPS. And just for those of you that know, HTTP is what you do your QVC shopping on, or your home shopping on, etc. So MQTT was co-designed by a company called IBM and a company called my employer, who co-designed it a long time ago and donated it to the open source community. And if you want to know which is better, so they're both supported by all clouds, do a quick Google search now and say, which is faster, MQTT or HTTP? Which is faster, MQTT or HTTP? And those doing CPDs, you get extra credit, the first one to come back with an answer. Andrew promised that. So,
Okay.
so the answer about that baked in thing is a good question. So what happens is that for those who don't know, to get messages, data back to a cloud, you would typically use, or using IoT, you typically use something called MQTT, and there's lots of versions. Rabbit, there's Hive, Active, there's lots and lots of versions. And the key comment is it's called a MQTT broker. And that, think of it as a server that sends messages. Who is it? The biggest messaging companies in the world use IoT and MQTT type messaging for their messages. And most of these I don't know any gateways that don't. All gateways will offer MQTT and HTTP. And what you do in your, I set it as a box, but was it 10 inches by 7? It's a small Linux box. In there, you've got a little program typically that will let you do some. So I also run another technical group called the Node-RED. So those of you at technical will know this is a technology called Node-RED. It's a flow programming environment, And in there, you have what's called, it's a drag and drop development environment. And you say, I want to talk to a Modbus box. You drag that onto the canvas. You want to talk MQTT back to AWS, and you drag that into canvas. It's not quite that simple, but pretty quickly you're getting the data in from a medical device and sending it to AWS or Azure or Google. So all gateways have that capability. And a word of warning, some gateways will lock you into a cloud. So say, this is our gateway, and it comes with something called TPM2 and MQTT, and it connects this gateway. But careful, careful, careful. Make sure your gateway can connect to any cloud, to simultaneous clouds, without being locked in. And what you'll find is some gateway manufacturers, if you try and move away from their cloud, that's where they get the money from. You will lose something called TPM2. That's a security feature, or you'll lose your maintenance. So that question, Colin, is brilliant. You know IoT. That's good, Colin. Thank you. MQTT is critical. So I hope those that are doing their CPDs have done that Google, and your answer should be something like 20 to 25 times faster, 90 or 93 times faster, whatever.
Thank you very much, Mike. And thank you, Colin, for your excellent questions. We go to Graham's question, which reads, how do you protect against malware entering the system or data being stolen via computers on the network?
Yeah, excellent question. So these gateways don't allow an inbound, sorry, let me change that. You set up your gateway so it does not allow an inbound connection from the outside. It only allows a connection from that medical device. So now you're thinking, that doesn't make sense. How do I do firmware updates? How do I do security patches? How do I connect to it? So what happens is you set your gateway up. As I've said, it only accepts incoming connections. It's completely closed up from anyone trying to connect in. So how do you do software updates? How do you do patches, etc.? How do you do that? Well, what happens is you design your system so that your medical data goes to your medical application. Your IT folks then have there's some open source applications. One's called Ansible. So those that are technical, look up at ANSIBLE. That's ANSIBLE. It's open source, and it's a set of playbooks. And what happens is when your gateway let's say a gateway is publishing data every 2 or 3 seconds to the medical application at the back end, it's also publishing a message outwards from the gateway to your IT people saying, hello, IT people. Have you got any updates for me? Any security patches, please? And it does that in an MQTT way as well, sends a message. And then so that the connection is outward bound from the gateway to your IT folks. And they go, yes, I've got some data for you. I'm going to send it now. This is a patch update or something. And doing that one gateway at a time when you've got 1,000 is quite difficult. So look up Ansible, ANSIBLE. I think it's .com. And you'll see that they've got lots of there's playbooks, and basically it's a scripting language, split the environment. And what you say is I've got 1,000 gateways and I'm going to update them, not all at once, obviously. You can update them for whatever. And then in your IT folks, they also have an inventory management system of all your devices, gateway devices, that is. And so you can maintain those. And also, by the way, because they're co-located with your UltraScan box or whatever your devices, you can also say that UltraScan 101 is due a firmware update or something. So I hope that answered it. So basically, no one can connect in other than your IT people, who, so as long as they're locked down and secure, you're secure.
Thank you so much, Mike. Thank you so much. You will like the next question from Adam. So. Yes. Throughout the presentation, it feels like you have focused on static devices or defined locations.
Yes.
How do the principles vary for in situ body devices such as pacemakers?
Such as?
Pacemakers.
Okay.
Which moves. Well,
yeah. So, all right. So there's, so I've done something similar with that same medical environment I described. What they've got there is they want patients to be able to go out of their homes. So they're not always, these are patients who are not too poorly, who have the ability to go out, and they have this only works if you have a mobile phone, and it works with Androids and Apples. And guess what? You've got an MQTT broker in that, and you got Bluetooth from the phone to your wearable device. So what happens, and there's two types of Bluetooth, there's BLE and BL. So this would more likely be a BL Classic is used for things like headsets and music type devices, and BLE is used for these wearable type devices, much lower power. And so what happens is your wearable device, whatever it is you have on, the qualification for this is you have to have a mobile phone, I'm sorry, and it has to be an Android or an Apple type phone. And so in the exact same way, the Apple phone has got a the wearable device has to have a BLE chip in it. And so that's that. So let me step back. Your wearable device has to have a BLE chip in it. I'm not saying they all do, but a lot do. And your mobile phone has got BLE in it anyway. You've got to download an MQTT client. Fine, that's fine. And then it publishes the data in the same way as the static devices. And you can actually track people using something called RTK. Oh, I'm getting very technical now. So I do some work with crop companies. Let me talk about this. It's quite important. And autonomous vehicles. You need to track those vehicles. So they're autonomous. They haven't got a driver. You have to track those down to the centimeter, i.e. if you're going down in fields, I've got real customers doing this, where they're planting potatoes, and this is in Europe, and you want to start tracking how much water and fertilizer you use and how many potatoes you get and where your tractor is. It's driving itself. You don't want it driving off the field, you know what I mean? So these highly precise GPS chips hold its position per centimeter. So you can get really accurate, but going back to your question, I've just shown off there, I'm sorry. So if you've got a wearable with Bluetooth, BLE, and a mobile phone, you can track the people wherever they are. And GPS there tends to go up within about 10 meters. So it can tell you where they are.
Thank you very much, Mike. Thank you. We have 4 more questions here.
Okay.
From David. Are there implications for meeting the MDR requirements as a medical device, given clinicians will be making treatment and or diagnosis decisions based on the presented data? Yep.
So great question. And I had this caused huge problems with projects I've been involved in, always does. And I have to get medical, I forget what the organizations are, but they've got level 1, level 2, level 3, and David, you'll know what I'm talking about. So remember I said that the gateway device, a couple of really important things. It does not send any data that identifies, so the technical people know this, no MAC address, no MAC ID, no IP address data, no patient address, no it's Mike from 15th Avenue. All it does is it takes the medical data, it attaches the gateway's unique identifier like 12457, whatever that is, and sends it encrypted over the internet. So nothing is identifiable. Now that's the first part. The second part is, and this is where David's coming from, I think, is we send everything. So going back to the industrial world for a minute, if I can do for a minute, if we're monitoring industrial machines, big generators, oil pumps, whatever they are, 99% of that data coming from that industrial machine is everything is fine, nothing's wrong. So why send it? You don't do it. However, in the medical world, you cannot do that. And I must stress this, in the medical world, the IoT gateway sends 100% of everything that comes through. It doesn't change it, it sends it all through. Because of that, the medical device has to be medically certified as far as it's medically safe, i.e., electrically safe. It's electrically safe to plug it into the patient's home or the medical environment. It does not have to be certified as a medical device. Think of the internet. When you plug something, when you plug your laptop into the internet, it doesn't, you might have to have the laptop checked to make sure it's electrically safe, but you don't check the internet is medically safe. So I hope that answered it, David. If not, email me. So I've come across, it's a good question. I come across it all the time.
Well, David just submitted another one. Are you using this for patient image DICOM transfer?
What's DI?
DICOM. are you using
I
this
don't know
for
what
patient
DICOM.
image by DICOM? Yeah.
So anything that's received can be transmitted. So I'm working on another project in another country where they're using it for real-time patient transit, so that when the patient's picked up from their home en route to the hospital, the second the paramedics arrive on site, they've got 5G cameras, etc., and they're sending images back. And when you take the patient into the ambulance, all the machines there are connected up and sending real-time imaging back to the hospital, so that when the patient arrives in the hospital's already got all the regular readings, but all the images you've mentioned, and that particular project uses 5G. And I don't know what DICOM is. I'm sorry, I apologize.
Okay, it's all right then. Thank you very much, Mike.
Okay.
2 more questions here from Doug again. Does each device have a unique MAC number to prevent any identification ambiguities?
Yeah, so absolutely correct. So each device had its own MAC ID, absolutely correct. And it has, so when it's connecting up to the back end, we use security X509 security certificates. They're also what's called TPM 2.0 secured. So for those that don't know, TPM 2 is what's called the hardware root of trust, and X509 certificates are the most secure method of making sure that the device that's sending data back to the back-end database is who it says it is, and vice versa. I think, and MAC ID, yes, each one's got a unique MAC ID. But again, the MAC ID is not transmitted with that patient data at all. It's not transmitted at all.
Right. Thank you very much, Mike. The last question here on the sheet from Sionade, perhaps I pronounced this name correctly. If not, my apology, please. It is the gateway that does the notifying of the device that is down, correct?
Okay, yeah, so normally, so if you've got some sort of medical device that is, let's go on first, but let's touch on the medical, let's do the medical device first. So the gateway can receive a lot of information from the medical device, and that information is different per manufacturer. So some manufacturers will send us data like, this is the CP, this is the temperature of the medical device internally, it's temperature of the CPU, etc. So we get to know how that machine's working. This is really important because you have something called AI and ML, and if we're monitoring 4,000 or 5,000 patients, and ventilator type A is 1,000 of them, we can get to know what a good profile is of ventilator A, because we're monitoring it. And we know that when the CPU temperature goes up to something and the fan goes on, we start to learn that machine type A is going to become faulty in three weeks or something. So that's the first thing. So we can be helpful with proactive preventive maintenance. We can only do that though if machine manufacturer's device is clever enough to send that data. The next thing we can do is the machine on? If we're connecting to it, depending on how we're connecting to it, we know if it's on or off. The next thing is, are we receiving data from the USB or from the RS-232 port or the Ethernet port? And we can do a couple of things to reset that. So if the device is not sending data, we probably know about it. Well, we will know about it. If it's switched, if the device has failed because someone's pulled the plug, or the device has failed, we know about it. We can then send those alerts back to the medical servicing company saying that we are, that we don't send the patient's data. Again, we send that reference number. This is from reference number 13457. Ventilator at this location stopped working. The next thing is, what if our gateway stops working? So remember, the ventilator is still working, the patient's not affected, he or she is getting their treatment, but our gateway stops working.
Right.
What happens is the cloud side of it is clever enough to say, the gateway stopped sending me data, there's a problem at the gateway. And that's quite useful, because it could be that the whole house has stopped working. You know what I mean? The power's gone off at the house. So the fact that our gateway stopped working, it might not be our gateway, it might be the house got a power cut. So it helps a lot. I hope that's helped and answered that question.
Thank you very much, Mike. That somehow concludes the QA session here.
Thank you.
Well, audience, thank you so much for these excellent questions. And please do send Mike, well, by email, any questions if you wish so. Thank you so much.
Thanks very much, Ashkan and Andrew. Thanks very much. It's great.
So, Mike, I have a few questions before
Oh, no! Go on.
Yes, so just to
Ashkan PhD, very clever. Go on. Right, hold on. I'm getting a fresh bit of paper.
So, so I mean, in IoT, there is a lot of data being transferred.
Mm-hmm.
So I think my first question is that which platform or software is being commonly used? Is this which you have been working on?
How do you mean it? So
it's like
at the cloud end or at the gateway end?
At the cloud end.
At the cloud end, it tends to be Azure, Microsoft, and Google and IBM are the main ones, and they tend to be. It tends, you know, I said at the very beginning about what someone asked me what the best markup protocol was. I forget the gentleman's name, and he mentioned JSON. What you tend to find in the cloud world, it tends to be whatever cloud the customer's got, you know, and all gateways can connect to any cloud. What you will find though, Ashkan, is that device management is different. So depending on the device IoT gateway manufacturer and the tools you're using. So Ansible, for instance, is very good. It should work on pretty much everything. But yeah, the best cloud to use is probably the one you're already most comfortable with, which I'm not ducking it. It's just they're all very similar.
Okay. And then, so have you had any experience of any like security concern or any issue with a database on the cloud side or the device itself?
There's a big thing going on right now. I think it's, I'm not screen sharing, that's good. Let me just check something. It's 62443, IEC 62443, I think. Is it? Yeah. So there's on the, let's go back to you again. There's a, until now, there's not really been any standard security standards for IoT devices, etc. You know, what was it? What's the government said? Design. Is everyone still on this call? Is everyone still on it? Are they?
Yes, we have everyone.
Ian Levy, who is the head of the National Cyber and Security Center, got in touch with me about 3 years ago. I patented a few security things, and Motorola, some large IoT companies, told me they own that technology.
Okay.
And Ian Levy, who's the director of National Cyber and Security Center, got in touch with me as a result of that. And he and I had a debate. He's really bright. If he's head of the NCSC, he's pretty bright. And his answer to security is software, mine's is hardware. But anyway, there's a new standard coming out called IEC 62443, or it's out. And companies are working towards that. And it does everything from the hardware at the gateway end to, as I described, about how you access data, how you access a device, i.e. it only dials out, how you build your device, i.e. the JVM, etc. What you find with gateways is that a lot of them are built on open source. In JVM, Oracle took control of the JVM and they've changed things, etc. So what you got to look at is your whole stack in the gateway. I'm not criticizing Oracle, by the way, but what you can look at is the whole stack, how it's built, how it's maintained, what the firmware levels are. Like, would you use Bluetooth 4 now? It's deprecated. Wouldn't use Bluetooth 5, etc. So you start at the gate. I start at the gateway, which is called the southbound end. You have to lock it down so no one can do anything, basically. So generally you go into proof of concept mode and you can do things. Then you go to production, you lock it down as it's described. Everything's encrypted from the gateway to the cloud. At the cloud, data is the triad. So those that are IT will know what I'm talking about. And it's all to do with integrity of the data, how it can be changed, how you can check the data. Ones and zeros flip in storage. You can get corrupted data in storage, believe it or not. So you don't just store data, you then got to make sure it retains its integrity. So you have people that are managing medical data. They have to be your processes must be GDPR and HIPAA compliant. So it's not like a normal industrial company. Everything to do with medical is even more compliant. Yeah. So whatever you're thinking of to do with security and data, you have to be even more security conscious with medical data.
Okay,
I
understand.
don't know if that's the correct answer or not, but it's ultra secure.
Yes, that's great. Yes. I think just one last question. So how do you think we could maximize the use of IoT in healthcare for medical devices? For instance, do you think if there is a regulations for how they develop the software, would this help to integrate?
No, then you're gonna, I'm against regulation. Keep it open source. I hope what I've described is that that medical device manufacturers, if you use an IoT gateway outside of that medical device, and it's an open source type gateway, and use open source, by the way, open source, for those that go, oh my God, it's open source, it's free. The bank's been using open source for over 20 years. They use, and the military, they use it because it's secure. You make it secure, you know what I mean? So if you've got an open source type gateway, then, and it communicates to any type of device, and if you use an open source, you have an open source development environment on the IoT gateway, that's your first application environment on the gateway. You have one there, and you have another application environment at the back end, and where you normally have your application. Then that's a great way of having software. Having said that, in the medical world, you cannot have an application on the gateway that does anything to the data. 100% of all data must be passed straight through unaltered. But so no, don't regulate software. Keep it. You know, the fact they've gone to XML is good. That's great.
Okay.
Could we have time for 2 very short questions, please?
Sure, Mike. Sure, go on.
Mckean, does the equipment need a SIL rating requirement? SIL rating.
SIL rings a bell.
SIL rating requirements.
That now I come across. There's machine learning stuff that talks with SIL and other thing. I don't think that's what you're talking about. If you can send the question through again, I don't get to see the question. You send it through, but spell it.
Well, it's SIL rating. Does it need an SIL rating requirement?
Can you send it again and just?
Well, Mckean, can you send an email to Mike, please?
Just saying what SIL is. I don't know what it is. I'm sorry.
Yes, okay, that's
basically,
fine.
medical gateways don't need anything to be other than. You need to know what you're doing to set them up correctly, so they don't, they do not breach medical regulations.
Yes, yeah, right.
But they have to electrically say. What I do come across is they have to have in-country certifications for carriers and in-country certifications. But
I'm sure you can expect an email from
thank you.
Mckean. And the final one is just a request. Please, can you repeat the IEC number for gateway security of full stack?
I think it's 62443. Well, I'll just double check. Hold on. Where was it? Hold on a minute. It is IEC 62443. Sometimes called.
I'm sure Ian has got it. Yeah.
Sometimes called ISA/IEC 62443, and it's to do with security, etc. You should also look at the. Hold on a minute. I've lost you all. It's also as part of the. Look at what's called the CVE. If you don't know what CVE is, look up. Do a Google search on CVE plus, I think it's MITRE, which is common vulnerabilities and exposures. So look up, do a Google search on CVE and MITRE, I think. What did we do before Google? You read books. Yes, it is. Well, so look up something called, do a search on CVE plus MITRE. There's a search box there, and put a search in there for like Dell servers, Cisco servers, and you'll find lots of updates, or gateways, same thing. You'll find security vulnerabilities.
Well, Ian says, many thanks.
Thank you.
With double exclamation marks.
Thank you to everyone.
That really concludes the whole QA session. Thank you so much for that.
Thank you.
Oh, thank you very much. Thanks, Mike. Thanks, Andy.
Thanks, Ashkan.
I just want to say thanks, everyone, for attending. I hope you've enjoyed it. If you would like to join us in IT or in IoT group or biomedical engineering group, please get in touch and we will provide more information. So if there is anything else, Andy and Mike, you would like to add? Otherwise,
well, thank you very much, really, Mike, for this providing this presentation and providing these excellent answers to the excellent questions.
Yeah.
And
All I've
Oscar,
got to say to everyone, join the IET. Look
Yeah.
at IET.org. It's an excellent place. So I don't know if Faraday Place is open yet, but if you're an engineer of any age, join the IET. It's full of people who want to share knowledge and learn. It's brilliant, brilliant, brilliant.
You see, this is it. Well, that's perhaps that's the closing line.
That's the closing line. Cheers.
yes,
Thank you so much. Thank you.
Thanks all. Thanks. Bye-bye.
See you again. Bye-bye.
Thanks. Bye-bye. Thanks. Bye-bye. Bye-bye.